Hi guys, and welcome to Lecture 6 of Python Programming with me, Mace. So we're still in the binary chapter, but you can notice that my shell is open, my Python shell, so we will still be using the sketchpad today. But in today's video, we're going to actually be learning how to implement the binary we've learned into actual code through bitwise and logical operators. So what are bitwise and logical operators? They do something called bit manipulation. Bitwise uses it actually. So it manipulates and changes bits at the binary level. So let's start with logical operators. So there are three logical operators that we'll learn today, which are AND, OR, and NOT. So what do they mean? So we've got, we'll start with AND, but first we'll create two variables. So let's say x equals true and y equals false. We'll see what the use for these variables are later. So these are both Boolean values. So let's start with the AND operator. Let's say we do x and y. False. So what does this actually do? So say you've got these two values and you do x and y. It returns false. And what AND operator actually does is it will only return true if both the operands are true. So if x and y are true, it will return true. So let's say we changed y equals true. And we go x and y. So now they're both true. And we'll see that it's true. So AND will only be true if both the operands are true. Okay. So the next one we're going to be going over is OR. So all of these are actually in English meaning, so it's really easy to understand. So let's go over OR now. So OR is true if either of the operands are true. So let's say, for example, we have x or y. True. So x or y means either of the operands are true. And yeah, one of them is true. Two of them are true actually. But as long as at least one of them is true, it will be true. So if we do x equals false. Oh, whoops. I did not do a capital. X equals false. Y equals false. And now we do x or y. We'll see that it's false because both of them are false. None of them are true. So it's, as I said before, the definition is true if either of the operands is true. So no, either of them are not true. They're both false. So we'll return false. So now we're going to go on to our next operator, which is the NOT operator. So NOT is true if the operand is false. So unlike the other ones, we only use one variable. So we can't do x not y. It doesn't work. We do not x, which is true, and not y, which is true. So what does this do? See, not will return true if the value is false. Yeah, it's confusing, but it will return true if the value is false. So true if the value is false. If we say, for example, x equals true, and we do x equals true, so then we'll do not x, it will do false. So it'll just return the opposite value to whatever the value is. X equals true because not x. So those are the three logical operators, and we use them a lot. We use them in like if statements, if statements, conditions, loops, so on. And we'll learn that in the next few chapters. So now that we know logical operators, we're going to go on to bitwise. And bitwise, there are more bitwise operators than logical operators. But what you'll see is that logical and bitwise operators are very related, because we have the bitwise operators. We have the bitwise operators of AND. So we have the bitwise operators of AND. We use the AND. We have AND. We have OR. We have NOT, which is also known as complement. We have XOR. Oh, whoops. And we have XOR, we have left shift, and we have right shift. So those are our bitwise operators, and what you just realized is the bitwise operators have AND, we have AND, OR, and NOT. So what does that tell us? It tells us that the logical operators are also incorporated in bitwise. But what's the difference? Because you may as well say, so we could do X and Y false. So what is actually the difference? And that's what we get into. So what the logical operators do, they return either true or false. However, our bitwise operators, we'll just clear some space. The bitwise operators, they do something different. They do not return just Boolean values, but they can return numbers as well. So let's start with the bitwise AND operator. So this is where binary comes in. So we've got the bitwise AND operator. So let's say we have 3 and 4, which is 0. Okay, so now let's actually check this on our sketchpad. So 3 and 4. Okay, first of all, we need to convert 3 to binary, and we need to convert 4 to binary. So what is 3 in binary? 3 is 2 plus 1, and 4 is 2 plus 2. So that's 0, 0. 4 is 2 plus 2, so it's 0. Oh, whoops, it's not 2 plus 2. 4 is, okay, let's actually get our tables up here. So we have our 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, 2 to the power of 2 equals 4, and that's how far we'll have to go. So 4 equals 4 actually, and 3 indeed equals 2 plus 1. Okay, so our 3 is 0, 0, 1, 1, whereas our 4 is 0, 1, 0, 0. Now what the AND operator does, so that's a very poorly drawn AND, yeah, whatever. Well, that's a poorly drawn AND. So what the AND operator does is it executes AND. So AND is if both of the values are 1, it will return 1. If anything else, it will be 0. So are both of them 1? No. 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 Our answer, 0. And if we just erase all of this and go back to our Python, we can see that it returns 0. So let's go with something a little bit more, let's go with something that won't return 0. So 7 and 9, which returns 1. So if we go on here and we write up 2 to the power of 0, 1, 2 to the power of 1, 2, 2 to the power of 2, 4. Oh wait, let's just write before we forget. 7 and 9. 2 to the power of 3 is 2 times 2 times 2, which is 8. 2 to the power of 4 is 16. And I think that's how far we'll go. So let's start with 7. 7 is 4 plus 3. 3 is 2 plus 1. So it's 4 plus 2 plus 1. 9 is 8 plus 1. Okay, so let's write the first one in binary. 1, 1, 1. 0. That's 7. 7 equals 0, 1, 1, 1. 9 equals 8 plus 1, which means it is 1, 0. Let's just put our places here. 2, 4, 8, 16. Oh, whoops. It's 1, 2, 4, 8. There we go. And that is our 9, because we have 1, 8 and 1, 1. So, now we know how to do AND, right? If one of them is 1, then it will be true. So, it's just like the logical AND, except for it can return a number. So, let's do 1 and 1. Are they both 1s? Yes. 1 and 0. Are they both 1s? Nope. Both 1s? Nope. Both 1s? Nope. And that is 1, just by looking at it. And if we go back to our Python, we can see that it returned 1. So that's our AND operator. But we still have another 1, 2, 3, 4, 5 operators. Yeah, 5 operators to go. Okay. So our next operator is OR. So let's go with our first example here, 3 OR. Let's go where OR is. OR. So OR is beneath your backspace, and it's the little, I don't know the name of the symbol, but it's below your backspace. So 3 and 4 is 7. So how does that work? 3 and 4 is 7. So let's delete all of that. We got 3 and we got 4. Actually, I had already calculated the value. Okay, yeah, 3, whatever. 3 and 4. Okay, so 4 is just 4, as we figured out before. So 1, 2, 4, 8, 0, 0, 1, 0. And 3 is 2 plus 1, as we figured out. So it's 1, 1, 0, 0. Now let's do the OR operation on both of these. So 0, 0, 1, 1, 0, 1, 0, 0. And when you do these operations, you don't actually have to... Oh, that looks like a 1. Let's just... yeah, OR. Okay, so when you do these operations, it doesn't matter which... If you switch them, because, you know, it'll always work. It's not like subtraction or real operations. It doesn't matter if this is on the bottom or this is on the top. That doesn't really make any difference. Okay, so let's do OR. Okay, so OR, what it does is if either or both of the values are 1, then it will return 1. So if either or one of the values are true, if either or both of the values are true, then it will return true. So are either of them true? Yes, this one's true. So we do 1. Are either of them true? Yes, 1. Are either of them true? Yes, 1. Are either of them true? No, they're both false. So we do 0. 1, 1, 1. So we'll just do 1, 2, 4, and we'll see that's 7. 4 plus 2 plus 1, 7. And ta-da, 7. So that's OR for you. Now, we're going to extend on OR with the XOR operator, which is the same thing. 3, 4. It will return the same thing, and that's not a very good example. Let's do something like 6 XOR 7, which will be 1. And if we do 6 or 7, 6 or 7, we'll get 7. So why is 6 XOR 7 1 and 6 or 7 1? Okay, so let's have a look at this. 6 and 7. So 6, let's calculate. So let's get our tables up. We'll just write them down. So we got 1, 2, 4, 8, 16. Okay, so let's calculate the value of 6. 6 is going to be 4 plus 2. 7 is going to be 4 plus 3, which is 4 plus 2 plus 1. And we've already calculated that. Okay, so now you're going to get 0, 0, which is 1, 1, 1, 0. And 4 plus 2 is 0, 1, 1, 0. Okay, so you got 6 and 7. So let's have a look at this. There is literally no difference between XOR and OR. OR is either or both of them are true. So with OR, if it's 1 and 1, it will be 1. 1 and 0, it will be 1. 0 and 1, it will be 1. 0, 0, it will be 0. So that is OR. Now let's have a look at XOR. Now what XOR is, it is OR but exclusive, which means it is exclusive to either, which means 1 and 1 is 0. And I'll get to that in a moment. 1, 0 is what? 1 and 0 is 1. 0 and 1 is 1, and 0, 0 is 0. So how does that work? XOR, only one of them can be true. They both have to be different. Only one of them can be true to return 1. So with 6 and 7, let's calculate this. So 0, 1, 1, 0, as you can see there. And 0, 1, 1, 1. So 0, 1, 1, 1. Okay, so let's do the OR operator first, which is this one. Let's just put operator so nobody confuses it for a 1. So 0 or 1. So we've already done this before, so I'm just going to plug in the answer. So that's 1, 1, 1, 0. Okay, right? So the 6 and 7, that returned the 7, right? But now let's do XOR. 0, 1, 1, 0, 0, 1, 1, 1. XOR. So let's do XOR. XOR was there. There we go. And let's do XOR. So let's go 0 and 1. That is 1. 1 and 1. That's where things get different. It's 0, 0, and 0. So that is 1. That is 1, and that is 7. And was that the thing we got in the shell? Yes, we got the 7 there and the 1 there. So XOR is the same as OR, except for XOR is only one of them, whereas OR is one of them or both of them. Now we go to our NOT operator, also known as complement operator, and this is probably the simplest one because it's really simple actually. So let's go on to the sketchpad here actually, so let's get rid of everything. Complement, also known as NOT, is the tilde sign, which is under your escape key. This is Windows. Shift the tilde, and that gives you your... This is very poorly drawn actually. Still poorly drawn. Yeah, that's good enough. That gives you your tilde operator complement, which is complement or not. So what did we see in NOT? NOT returns the opposite. If you put 0 in, it'll give you 1. If you put 1 in, it'll give you 0. So that's what it does here. If you have 0, 0, 1, 1, which is 1 plus 2 equals 3. And if you have 1, 1, 0, 0, which is, actually no, let's change that to 0, 1, 1, 0. And that is, let's see, 1, 2, 4, 8. 4 plus 2 is 6, equals 6. Okay? So let's do complement for both of these. So unlike the other ones, we don't do complement like this because, yeah, that's not how it works. So we do 0, 0, 1, 1. The complement of 0, 0, 1, 1 is 1, 1, 0, 0. It literally just turns 1 into 0 and 0 into 1. So the complement of 0, 0, of 3 is, let's have a look, 1, 2, 4, 8, is 12. And the complement of 6, so let's put 6 in, the complement of 6 is 1, 0, 0, 1. So the complement of 6 is, let's see, 1, 2, 4, 8, is 1 plus 8 equals 9. So let's try that. Let's do complement of 3, which is 12. So complement of 3 is minus 4. Complement of, what was the other one we did? We did 6, right? Minus 7. So what are we noticing? They're minus. Why does this happen when we put complement into our thing? So yeah, complement is the opposite. Complement or not, it is the opposite. So what's going on here? Why is it returning to us minus 4 and minus 7? And that's why we went through negatives in the last video. Minus 4, minus 7. Actually, let's just look at this. So yeah, complement of 3 was minus 4. Oh, whoops. Okay, so complement of 3 was minus 4. So it should have been 12. It was the opposite. Complement of 3, should have been 12. But why wasn't it 12? It was minus 4. So let's write 12 out. 1, 1, 0, 0. And let's write 4 out because, yeah, why not? So 4 is 0, 0, 0, 1, right? Oh, whoops. No, it was 0. So right now what we're looking at here is the opposite. So the opposite of 3 was 0, 0, 1, 1, right? So why do we get minus 4? So why is it coming up like this? So what we said before was complement was simply the opposite. So if we come with 3, 0, 0, 1, 1, complement should have been 0, 0, 1, 1, which is, I said it the other way. So why on the console did it come up with a totally different negative number, minus 4? Why did it come up with that? Oh, whoops. That's the question. So what we use now is 2's complement, but not like we used it in the last video. So for the complement, we got -4, right? So how do we convert this to -4? What we were expecting to get was 1, 2, 4, 8. What we were expecting to get was 12. But what was the reality? We got -4. So why is this? So we got to find out how this translates to this. Okay, so 1, 1, 0, 0. What we've got to do is first of all do the complement of our answer, which is literally the original 0, 0, 1, 1. However, for this we actually add a 1 to it. So we go +1. So we know how to do addition, right? We do 1 + 1, 2. No, it is not 2. It is 0, and then we carry the 1 over. It's 0. We carry the 1 over. We have 1, 0. And what do we have here? Let's just do 1, 2, 4, 8. And what do we have here? We have a 4. So now you can see how we got -4. Oh, whoops. So now we can see how you got -4 because that connects up to that. But how is it negative? Sure, you've got this 3 + 1, but isn't that just going 3 + 1, 4? So isn't complement just adding 1? Let's check that out on the console. Okay, so let's just check that out on the console. So let's go complement, which is this operator, remember, and we go 4 -5. So that just added 1 and made it negative. So let's check another one out, and let's make this a real big number. 1, 2, 3, 4, 5. 1, 2, 3, 4, 6. What about tilde? 5, 8, 6, 5, 8, 3, 6, 7, 2. 5, 8, 3, 6, 7, 3. Now let's go tilde. 0. -1. What about tilde? 1. -2. What about tilde? -2. 1. So what you just realized there is that complement will convert it to the other like type. So if you do positive, it'll convert it to a negative. If you do negative, it'll convert it to a positive. So complement changes the type, so from positive to negative, negative to positive, and positive. And how it does that is simply by adding that extra 1 and then turning it into negative because it's 2's complement. So it's literally like you have the answer, you've got the complement, but then you complement the complement. You make the answer opposite, and then you get the 0, 0, 1, 1. So really, complement just takes the first value and adds 1 to it. Okay, so that's your complement operator. So you can see that I actually cleared out our shell. Now let's go to our next bitwise operator. Our next bitwise operator is the right shift. So right shift is actually quite interesting. Say for example we have right shift. So right shift is that symbol, 2 of the caps that are sideways. I don't know the name for them. Right shift 6. Oh, whoops. Oh, I got that wrong. Okay, so we do right shift 6, right? We got to do 2 numbers. So we've got to do the number we have in 6 right shift 2. 1. But why didn't it work here? Why didn't we could do just right shift? Why didn't it work like that? It's because you need another value. Unlike the XOR we saw, the complement, sorry, we saw before, we need 2 values. Okay, so how does right shift work? Right shift is literally, say you have a number 1, 0, 0, 1. And that should be 1, 2, 4, 8. That's 9, okay? That's 9. And say you put, so let's just move that down. Say you put the 1001, put decimal point 0000. And the decimal point, it exists even though we ignore it because they're zeros, they're valueless. So what right shift does is it shifts your bits to the right. So if you have a look here, actually let's go with left shift first because it's easier to understand. So if we go here and we have our extra zeros, what left shift does is you gain bits. You are literally moving this decimal place two bits. Wait, how many bits? Yeah, we're moving 2 bits to the left. So now it's 100100. And that changes your value. So what we actually did in the console here was we did 6 right shift. In fact, we will do 6 left shift because it's just easier. 24. It's not easier actually, it's just it's easier to understand before we go into right shift. So 6 left shift 2 is 24, and that's what we did here. We put that's what we did here. We did left shift to the 6 to the 9, sorry. We actually did 9 left shift 2. That's 36. Okay. And let's check if this is 36. So we got 1, 2, 4, 8, 16, 32. I am almost certain. 32 plus 4, 36. So what we just did here is we took these zeros and we shifted it. Now, let's go on to our next one, which we did before, but then I quit. So by logic, in left shift, if you're gaining bits, then in right shift, you're losing bits. So say we have 9. Oh, whoops. Oh, yep, that's right. Oh, no, it isn't. That's right shift. 9 right shift 2, you're losing bits. See? 36 2. So let's do 9 right shift 2. So 9 is 1001. Now, this isn't true. I'm just imagining here. But let's just imagine there are 4 zeros here on this side instead. And what we're doing in right shift is we are literally losing bits. So we're moving. Oh, we don't actually need those zeros. Let's just put the decimal. Remember, you don't really put the decimal at the start. This is just being purely hypothetical. So we move 1 to the side. This is moving it to the right. 1 to the side. And 10. And that splits us there. So what you get right now is, what did we get? We got 2. And if we go back to our paint, you can see that we got 1, 2. Ta-da! So all we're doing is just cutting off the bits on the right. Whereas on left shift, we're adding bits. So you get a larger number in left shift. You will always get a larger number than right shift. Because right shift, you lose bits. Left shift, you gain bits. So those are your bitwise and logical operators. And in the next video, we're going to go on to talk about the bitwise and logical operators and really cool tricks you can do. Such as how, I'll just hint one here, if you do 2 XORs, you're going to get back to your original value. So they're just little tips and tricks like that. And at the next video, we'll end up this chapter. And in the next chapter, we're going to go over completely different things. So bye guys, and thanks for watching.